Today we'll be looking at the Unit 3 test review for pre-calculus. Before we do any of these problems, let's just take a look overall. We've got 15 problems on this test review, and this is going to follow the same format for the test itself, just like every other test and test review that we've done. So you can expect for the day of the test, there are going to be 15 problems just like these. All right, let's jump into it. Number 1. Evaluate the function f of x equals 3.3 to the x for x equals 2. Okay, so on my calculator, I'm going to plug in 3.3, and I'm going to bring this to the power of 2. All right, so that's 10.89. Number 2. Evaluate the function f of x equals e to the x for x equals 1.5. All right, on my calculator, to get to e to the x, which is right here in the background, because that's in blue, I'm going to hit second. And then now it turns on all of these blue modes. I'm going to click right here to get e to the x and then put in 1.5. All right, this is 4.48. Number 3, evaluate the function f of x equals log base 10 of x. So in the calculator, I've got 2 buttons for logs. The first button, just regular log, is the logarithm of base 10. And the second one, ln, this is the log of the natural number, so this is going to be base e. These are the only 2 bases that we can do with our calculator. Luckily, this is base 10, so I'm just going to hit log here, and then put in 33. Okay, this is 1.518. I'm going to round this to 1.52. Number 4, evaluate the function f of x equals the log of the natural number of x, or just ln x. This has its own button. The natural log of 22 is 3.09. Okay, number 5. For problem 5, complete the table to determine the balance for a principal of $3,500 invested at rate R for T years and compounded N times per year. It says, hint, use P times 1 plus R over N to the NT and PERT, P times E to the RT. All right, so P is the principal. That's $3,500. That's what I'm putting into the account to start out with. So let's write that down. P equals 3,500. Okay, R is the rate, which is given to me here at 1.5%. But I want this not as a decimal. I want this as, or not as a percentage here. I want to find this as a decimal. So 1.5 divided by, it's out of 100%. So 1.5 divided by 100. Alternatively, you could just move the decimal place 2 spots. This is 0.015. Okay, T is 10 years, and then N is going to change. Now, continuous at the very end here, this is the only one where I'm going to use this PERT equation. All of these other ones are going to be using P times 1 plus R over N to the NT, and N is just going to change as we go. So let's clear everything we've got here. And let's plug in. P is 3,500. Parentheses, 1 plus R is 0.015 divided by, in this case, N is going to be 1, And this will be brought to the power of nt. So I'm going to do 1 times 10. This is 4061.89. All right, now n is going to be 2. So I'm essentially going to plug in the exact same thing that I did right here. Okay, so I can even do this. And then now just change all of these 1s to 2s. So that's going to be a 2 there. And then that will be a 2 there. $4,064.14. All right, now n equals 4, so I'm going to copy this again. Go up twice, enter. And then we'll change the 2's here to 4's. Okay, enter here. 4065.279. We'll round that up to 0.28. So 4065.28. All right, now n is going to be 12. So we'll change the 4's here to 12. Same up here. We'll do 12. Then make sure that's times 10. This is 4066.038. We'll round that up to 0.04. So 4066.04. All right, one last one with this equation. Now 365. So n is going to be 365. So we'll copy it one last time. And let's change these 12s to 365. All right, 4066.407. So we'll round that to 4066.41. Now for this last one, this is continuous. When you see continuous, that tells you to use the PERT equation, which is completely different than this one. So let's plug this in. P is 3,500. Times e to the, so we'll do second, make an e to the x, and then RT. So this will be 0.015 times t is 10. $4,066.42. So as you see, as n increases, or the number of times we compound per year increases, the amount of money that's in the account after this 10 years also goes up. Okay, 6 and 7. Write the logarithmic equation in exponential form. Here I've got a hint. Log base 5 of 25 equals 2 can be rewritten as 5 to the second power equals 25. Okay, so basically, I've got a little saying that goes with this one. The base of my logarithm is the base of my exponent. So the base of this logarithm, base 5, ends up being the base of this exponent, and then you switch. So you go to the other side of the equal sign, you find this 2, so 5 to the second power equals, you switch back to the other side, 25. So for our problem here, log base 2 of 22.63 equals 4.5. Start with the base. The base of my logarithm is the base of my exponent. 2, switch to the 4.5. This is equal to 22.63. And you can confirm this in your calculator. If you put in 2 to the 4.5, you'll get something pretty close to 22.63. This might be rounded a little bit. So 2 to the 4.5. And so it's 22.627, pretty close to 63 here. All right, natural log of 91 equals 4.51. Remember that the natural log is technically just a shorter way of writing log base e. So if this is log base e, the base of your logarithm is the base of your exponent. It would be e, switch to the 4.51, switch equals 91. So e to the 4.51 equals 91. Again, if you want to check your answer, make sure that you're pretty close to having that correct here. So second, e to the, and then 4.51. We should get something really close to 91. So 90.922, essentially. Pretty close. And if we can write going from logarithms to exponential equations, then we can go from exponents to logarithms. So number 8 and 9, we're just going to do it backwards. 9 to the 2.5 equals 243. All right, same kind of rules here. We're going to go, the base of my logarithm is the base of my exponent. So this base is 9. This will be log base 9. And then switch. So log base 9 of 243 equals, switch back over, 2.5. Number 9, e to the third power equals 20.085. This is a base e, so I'm going to do log base e, or shorthand, the natural log, of switch 20.085 is equal to, switch back, 3. Okay, second page. For problems 10 and 11, evaluate the logarithm using the change of base formula and a calculator. All right, this log base 11 of 19 is not something that I can put into the calculator right away, at least not as it is. That's because, as we talked about, the calculator here can only do log base 10, our common log, or the natural log, so log base e. Since this is log base 11, what I need to do is change the base to be able to put something into the calculator rather than look at this as log base 11 of 19. My change of base formula says that this log base 11 of 19 is the same as, you write a fraction, and in the numerator, you can either use log base 10 or the natural log, since either of those are ones that you can use in your calculator. I'm just going to use natural logs here. So we'll do the natural log on top, and we'll do a natural log on bottom. On top, this is going to be what you were taking the logarithm of before. So you were taking the logarithm of 19. On the bottom, this is going to be your old base. So your old base was 11. Now I can put this into a calculator. So over here, I'll put in a natural log of 19 divided by the natural log of 11. So this is 1.2279. We'll call that 1.228. Now, just to show you that you could have used log base 10 as well, here I'll plug that in. Log 19 divided by log 11. Just make sure that you don't mix these up. If you're using logarithms, base E, so natural log, you have to do that for the top and the bottom. If you're doing logarithms base 10, you've got to do that for top and bottom. So you'll get the exact same thing though. All right, number 11. Log base 6 of 21. Again, not something I can put into the calculator, at least not as is. I'm going to have to do a change of base formula. So this is going to be equal to a fraction. Numerator, I'm just going to use natural logs again. So I'm going to do a natural log on the top, natural log on the bottom. The top part is going to be what I was doing the logarithm of before. That'll be 21. And for the bottom, this is my old base. So the old base here is 6. Now I go over to the calculator and I put in the natural log of 21 divided by the natural log of 6. And that's 1.699. Okay, next part, 12 and 13. Solve the exponential equations. I've got 3 to the power of negative x over 2 is equal to 0.111. All right, to solve these problems where I've got x and it's this x that I'm looking for is stuck inside of an exponent here, what I need to do is take both sides to some logarithm. Now, how do I know what base to use? That's going to be dependent upon what base you see here. Okay, so it's 3 to the negative x over 2. 3. This tells me use log base 3 so that I can use my inverse property and get that 3 out of there, bring this negative x over 2 down to our main line. So log base 3 of 3 to the negative x over 2. This is going to be equal to log base 3 of what I do to one side, I have to do the other side. So log base 3 of 0.111. Now, as discussed, this log base 3 and this 3 right here, these are going to undo each other, leaving just whatever this exponent is, so negative x over 2. So I will get negative x over 2 equals log base 3 of 0.111 is not something that I can just put into my calculator. So here I'm going to have to use another change of base. Let's do natural logs again. So let's do the natural log of 0.111, natural log of what I was doing, taking the logarithm of before, over the natural log of my old base is 3. All right, negative x over 2 is equal to, let's find out what this is, natural log of 0.111 divided by the natural log of 3 . This is negative 2.0009. That's pretty close to negative 2. We'll just round that to negative 2. And then to solve for x, I can multiply both sides by this negative 2. Okay, x is equal to negative 2 times negative 2 is going to be positive 4. All right, next I've got 70 times e to the 0.45x equals 400. I've got to get this e to the 0.45x by itself. So let's isolate that by dividing both sides by 70. E to the 0.45x this is going to be equal to, let's go in here, 400 divided by 70. This is roughly 5.714. All right, x is stuck inside this exponent. The base here is e, so what I'm going to have to do is bring both sides to some logarithm, put it inside a logarithm, base e, because this exponent has a base e. So that's the natural log. The natural log of e to the 0.45x is going to be equal to the natural log of 5.714. My inverse property will say my natural log and this e will undo each other. Leaving 0.45x is equal to and then let's find out what this is. The natural log of 5.714. This is 1.7429. We'll call that 1.74. Okay, if you want to go one more place, you can go 1.743 if you really want. And we'll divide both sides by 0.45. Okay, x is equal to, we'll just take this and we'll divide by 0.45. So about 3.87. Okay, last two problems. Number 14 and 15, we're solving a logarithmic equation. So for 14, I see I've got log base 17 of both sides here. Log base 17 of 4x plus 1 equals log base 17 of negative 3x. Well, this is going to be my one-to-one property, saying if I've got log base 17 of this thing is equal to log base 17 of that thing, well, they're both log base 17. If they're equal to each other, then whatever's here should be equal to that. So 4x plus 1 should be equal to negative 3x. Okay, so now just bring all the x's to one side and bring everything else to the other side, solve for x. Here I've added 3x to both sides, so this will make 7x plus 1 equals 0. Let's subtract 1 from both sides. (7x) is equal to negative 1. And then divide both sides by 7. Okay, x is equal to negative 1/7. You could leave it like that. Okay, or we could say, if we just plug it into a calculator, negative 1 divided by 7. This is about negative 0.14. So I would take either answer here. Okay, last problem. Negative 4 plus 2 times the natural log of 3x is equal to 17. All right, let's get this natural log of 3x. Let's try to isolate that in some way. So I've got negative 4 plus this thing equals 17. Here, let's add 4 to both sides. Okay, 2 times the natural log of 3x is equal to 21. Almost there. We're going to divide both sides by 2. So this will give me the natural log of 3x equals 10.5. Okay, now that I've got the natural log of 3x equals 10.5, x is stuck inside this logarithm. More specifically, the x here is stuck inside this logarithm with a base e. So what we're going to do is exponentiate both sides here. And we're going to say e to the left side is equal to e to the right side. So e to the natural log of 3x this is going to be equal to e to the 10.5. My inverse property will say e and then this log base e, so e to the log base e. This is all going to undo each other, leaving just whatever's inside this logarithm, 3x. So I've got 3x is equal to e to the 10.5. Lastly, let's solve for x. We're going to divide both sides by 3. Okay, x is equal to e to the 10.5 over 3. Plugging that into a calculator, let's see. E to the 10.5 over 3. and we're dividing this by 3. So this is 12,105.17 is what we'll round that to. Okay, and that does it. There's all 15 problems. Your test is going to look very similar to this, just with some different numbers, different problems, but pretty much the same format. So study up and let me know if you have any questions.